Hey guys, welcome back. We now understand some key important file formats, and not only we understand the concepts, we also saw how to use them along with MapReduce. But in the past couple of years, for the ease of development, most companies use tools like Apache Pig and Hive. And hence, it is very important that we know how to use these file formats with those tools as well. So in this lesson, we'll talk about how to deal with compression, sequence files, and Avro files in Apache Pig. Let's start with compressed files. Dealing with compressed files in Apache Pig is super simple. Let's first see how to store compressed files in Pig. We know compression can be enabled at the map output or at the job output or at both locations. To enable compression with MapReduce program, all we did is enable compression with simple property settings. And that is it. The rest worked like magic. That is exactly the case with Apache Pig as well. Here again, we'll set three properties. The first property enabled the compression for the map output. The second property enabled the compression for the final output. Finally, we need to choose a codec that we would like to use for compression. In our example, we are going to use gzip codec as our codec. There you go. All three properties are now set. When you set these properties in the grunt shell, the properties will be in effect for the current session. That is it. Now, when you store files using Pig from this grunt session, the output will be automatically compressed in gzip format. Also, the output of the mappers will be compressed as well. To demonstrate compression in Pig, we need a relation to store. So let's use the load operator to load the stocks dataset first. Let's run this instruction in our cluster. There you go. Now that the stocks dataset is loaded, let's now execute the store operator to store the stocks relation in HDFS. And here is the store instruction. The output will be stored to output/pig/compressed in HDFS. So let's execute the store. And this is going to execute a MapReduce job to store the output in HDFS. The store operation is now complete. Let's now review the output location of the store instruction in HDFS to make sure whether the output is compressed or not. So this is the output location. Let's do a listing on the output location. As you can see, the output file name is partm000.gz. You see the extension of the output file is gz, which means the output file is compressed using gzip. Now that we know how to write or store files in compressed format using Apache Pig, let's check out how we can read a compressed file in Pig. Again, very simple. Just make sure that the compressed file has the appropriate extension and Pig will take care of the rest. In the compression lesson, we saw as long as the file extension you have is mapped back to the codec, your input format will not have any problem loading the correct codec and uncompress the file. That is the same situation with Pig. See, there is nothing different with this load instruction. Since our dataset is with extension .gz, Pig understands the dataset is gzip compressed and can load the compressed dataset with ease. It works like magic. So let's run this load instruction in our cluster. I always like to see the proof that it actually worked like magic. So let's print 10 records from the just loaded relation just to make sure that the compressed dataset was read properly. So here are the two instructions to limit the output to 10 records. There you go. Let's wait for the execution to complete. We were able to read the compressed records just fine. Okay, let's move on to look at sequence files. Let's try to read and write sequence files using Pig. Refer to the sequence file lesson in this chapter to understand the structure of sequence files. But in short, sequence files are made up of records. Each record has a key and a value. Sequence file can be compressed either at the record level or at the block level. Let's see how we can load a sequence file first. To load a sequence file, First we need, you guessed it, a sequence file of course. So we are going to use the sequence file which we created in the sequence file lesson. The file we have is basically the stocks dataset stored in sequence file format. As said, sequence file is made up of records and each record has a key and a value. So you can store only 2 values per record. So what is in each record of the sequence file that we created? We stored the length of the line from the stocks dataset as key in each record, which is not a significant column for us. But anyway, we'll load it. Whereas the value in each record has the line from the stocks dataset. Here's what we're going to do. Let's load the sequence file dataset, which is nothing but the stocks dataset in sequence file format using pig, and calculate the average volume by stock symbol, and let's store the output as sequence file as well. Sounds like a plan? Just like pig has an out-of-the-box pig storage load function to load plain text files, it offers sequence file loader function to load sequence file. So to use this function, you have to register the piggy bank jar and also you have to define the function. That is exactly what we are doing in the first 2 lines. In the second line, you're saying define sequence file loader and the actual fully qualified name of sequence file loader. Here is the load instruction. Keep in mind that each record in sequence file has a key and a value. So we are defining only 2 columns. The first column is for the key and the second column is for the value. In the value column, we stored a line from the stocks dataset, and a line in the stocks dataset is a comma separated list of values like symbol, opening price, closing price, high, low, and volume, etc. Once you execute the load instruction, the SCQ underscore dataset will have all the records from the sequence file. So moving on to the next instruction. To calculate the average volume by symbol, we need to extract symbol and volume from the line of text which is stored in the value column in SCQ underscore dataset. So we'll use the string split function to do that. String split will take in 3 arguments. The first argument to the string split function is the string you want to split. And the second argument is the character which is used to split. Since comma is the delimiter, we'll specify comma, and there are 9 fields or columns in each stocks record. So we have mentioned 9 to split all the 9 columns. In the next instruction, we are projecting just the symbol and volume because for our average volume calculation, that is all we need. Here we are using the column positions to get the columns, $1 for symbol and $7 for volume. Next 2 instructions does the actual grouping and calculate the volume. These instructions sure will look very familiar to you from our pig lessons. Let's now execute these set of instructions in our cluster. Let's first register the jar. Let's now define the loader function. Now the load operator. Now we are going to split the stock records using the string split function. We're going to project just the symbol on the volume. There you go. Now we're going to group the records by symbol and then calculate the average volume by symbol. Now the AVG underscore volume relation will have the average volume by symbol. Let's see how to store this average underscore volume relation as a sequence file. Pig does not offer an out-of-the-box function to store output as sequence files. Hence, we'll use a library called ElephantBird. ElephantBird is an open source project from Twitter, and it has several useful functions for Apache Pig, along with several other useful functions for other big data related projects as well. Get the name ElephantBird? Elephant for Hadoop and bird for Twitter. Okay, fun facts aside, we are going to use a function named sequence file storage from the ElephantBird library. To use the function, first we have to register few jars from the ElephantBird library. And then we use the store operator along with the sequence file storage function to store the output. The 2 parameters to the function sequence file storage indicate the key and the value type for the record in your sequence file. We are going to store the output as text for both key and value. In our case, the key will be the symbol and the value will be the average volume for that stock symbol. Let's now register the jars and execute the store instruction. Let's now run the store instruction. This is now complaining that the output location already exists. So let's delete this output location and then rerun the store operator. There you go, the output location is now deleted. Let's now run the store instruction again. The store operator, as usual, will execute a MapReduce job to store the relation into the output location specified in HDFS. Let's wait for the execution to complete. The execution is now complete. Let's now review the output from the store operator. Here is the HDFS listing on the output folder, and here's our sequence file. They don't usually have an extension indicating a sequence file, so let's copy the file to the local file system and try to open the file. There it is. The file isn't binary, so it is not readable. But as you can see, the file starts with SEQ, which is a clear indication it is a sequence file. And it also has the type for the key and the value for each record. In our case, both the key and the value are of type text. So that is what you're seeing here. And also we have enabled compression at the very beginning of this lesson. So the records are also compressed using gzip codec. If we still want to see the output in text readable format, we have to use fs-text instead of fs-cat to see the contents of the sequence file. So let's run this in our cluster. Here is the output in plain text readable format. Now so far we have seen how to deal with compression and sequence files in Pig. Let's now look at how to deal with Avro files in Pig. Just a short recap about the Avro files. Avro is used when you need interlanguage portability. For instance, when there is a need to write a file in binary types using Java and read the same file using Python. In such an instance, we could use Avro to serialize and deserialize the file. With Avro, you define a schema and you use Avro libraries to serialize and deserialize the objects to and from the file. That is exactly what we saw in our Avro lesson. Now we are going to see how to load and store Avro files using Pig. In this set of instructions, we'll first load our stocks dataset, which is in text format, and store the same dataset using Avro. Once we store the dataset in Avro, we'll then see how to load the Avro dataset in Pig. To work with Avro in Pig, you need to register few libraries first. The Jackson and the JSON libraries are used to parse the schema of the objects in Avro. Since the schema is in JSON format, we need these libraries. The load operator here is very familiar to us. Once the stocks dataset is loaded as usual, we will use the Avro storage function to store the stocks dataset in Avro format. Here we have to specify the schema of how we intend to store the objects. The name of the object is stock, and in the schema we define each column and its types. If you look at the schema, we have exchange, symbol, opening, closing prices, etc., representing all the columns in the dataset. When you run the store instruction, it will save the stocks dataset in Avro format, and Avro will use this schema to encode the contents in binary types. Let's run these instructions in our cluster. Let's first register the jars. There you go, the jars are now registered. Let's now run the load instruction to load the stocks dataset. Okay, the stocks dataset is now loaded. Let's now execute the store instruction to store the stocks relation as an Avro file using the Avro storage function. The store operator will execute a MapReduce job. So let's wait for the MapReduce execution to complete, and let's then review the output. The execution is now complete. Let's now review the output. So let's do a listing on the output location in HDFS. As you can see, the output file name has .avro extension indicating it's an Avro file. Let's now open the file. We'll first copy the file locally from HDFS to the local file system, and then let's try to open the file using VI. As you can see, the file is binary and hence not readable. But at the very beginning of the file, you will see the schema that we specified with the store operator. We have now seen how to store a dataset using Avro. Let's now see how we can load the same Avro dataset in Pig. To load an Avro dataset, we have to again use the Avro storage function. Again, we have to specify the schema. Previously, we hard-coded the schema with the store instruction. Here we are choosing to supply the schema using a file. The file has the same schema and it's in HDFS in this location right here, avro/stocks.avro.schema. The schema will define the columns and its types in the file and will load the dataset. The schema in this file is exactly the same as what you see here. Let's run this load instruction first. So now we have loaded the Avro file in Pig, and it's stored in relation stocks_avro. Let's just print 10 lines from stocks_avro just to make sure we can read a file in Avro using Pig. So here is limiting the records to 10, and let's dump the top 10 relation. So here's the output. We are now able to load an Avro dataset in Pig, and we are able to display the data as well. Not that difficult, right? As I already mentioned in the beginning of this chapter, knowing to work only with text files just won't cut it in a real production Hadoop environment. In a Hadoop environment, you will see various different file formats, and you should be able to work with those file formats comfortably. Now you know how to work with compressed files, sequence, and Avro files using Apache Pig. Those are some very key and important concepts you just learned, and will definitely help you when you start working in Hadoop in the real world. With that, let's wrap this lesson. See you in the next lesson.